Welcome back, guys. This will be the last set of example problems in the notes with Fnet equals MA. We're going to add in the last thing, which is an incline. But before we do, I want us to look at another pulley problem. Again, we will assume that this is an ideal pulley, which means it's both frictionless and massless, and our strings are massless. All right, so we have a 2M block on this side pulling down. We have 1M block on that side pulling down. You would expect that this one would win out. All right, I'm going to have you guys look at this a little bit different, a little bit simpler, if you don't have to show all your work. We know that the second law applies to this. And that tells us that all of the forces combined together is equal to all of the masses times the acceleration of the system. So, first off, easy part. What is the total mass of this system? It would be 2M plus M, which is 3M. So that's going to go here. All right, second part, what is the net force? We know the tensions are internal. Once they're canceled out, once they're gone, what really is working against each other? It's 2mg, the weight of the 2m block, and mg, the weight of the 1m block. So really what you're left with is that mg is equal to 3m over A. A is going to be equal to G over 3 because the mass cancels out. All right, last example is going to be inclines. I have a turtle being held on a frictionless incline by a string. I'd like to know what the normal force is. I'm then going to cut the string, and I want to know what the acceleration will be and how long it'll take to slide 10 meters down the incline. So tension is going to go up. Normal is going to go normal, which is perpendicular. Weight's going to go straight down. I'm going to pick this up, spin it, and put it back down. So it's no longer a free body diagram. My angle is up there. I'm going to find these components. I want the one that's opposite normal, and it's going to be that one, and that one is mg cosine of 60. And I'm going to say perpendicular to the incline, Fnet is equal to 0, n minus mg cosine 60 is equal to 0, n is going to be equal to mg cosine 60. So this is going to be 1 kilogram times 10 meters per second squared times cosine 60 is our normal. So cosine 60 would be 1/2. 10 times 1/2 would be 5. Part 2. We are cutting the string and letting this turtle go. All right, my free body diagram is going to change. Now I just have mg down and normal perpendicular. I'd like to know what his acceleration would be. I'm going to pick up this and spin it. It's going to look similar to the one I just drew, but it's going to lack the tension. And now I'm going to find the components of the weight. And now, looking at our components, this one's balanced with that one. There is nothing to balance this one. This is the opposite side, so it's going to be mg sine of 60. And so I'm going to say, parallel to the incline, Fnet is equal to ma. And so I'm going to have mg sine of 60 is equal to ma. M is going to cancel out, just like when we first dropped the block in the first example problem in this section. And your acceleration is going to be g sine of 60, which is going to be 8.66 meters per second, 8.7 meters per second. Then how long is it going to take to go 10 meters? I'm going to have a chart. And then I'm just going to solve for time. That's going to go away. I have 2 times the distance divided by the acceleration, square root. And so I'm going to have 2 times 10 meters divided by 8.66 meters per second squared. And I have 1.5 seconds.